I'm Anil Kumar, and in this video we'll explore discrete sequences which are neither arithmetic nor geometric. The question here is, determine the recursive formula for the sequence 7, 20, 59, 176, 527, 1580, 4739 and so on, right? So that is the question given to us. We need to find recursive formula. Recursive formula means we have to write a formula which relates with the previous term. Now if you see the sequence, it is not arithmetic since the common difference does not exist. But the numbers go rapidly up. So it is close to geometric, right? So let us see what do we get by finding the ratios. So what I will do is I'll just calculate ratios for the consecutive numbers. So we have 7 and 20. So let us find what is 20 over 7 equals to. Then we have 20 to 59. So we'll calculate what is 59 over 20. Then 176 over 59. 176 over 59. And then we'll calculate 1580 divided by 527. Okay, so I missed one in between. That's okay. Anyway, so we'll calculate these ratios now. Okay. So what is 20 divided by 7 equals to? In decimals, it is 2.85. So let us write 2.85 here. 59 divided by 20 equals to, in decimal, it is 2.95. Then we have 176 divided by 59 equals to, in decimals, it is 2.98. And then we have 1580 divided by 527, which is in decimal 2.99. So what you see here is that as this series progresses, our ratio is closer and closer to 3. Do you see that? So it is closer to 3. That gives us an indication that times 3 is kind of there in the relation. Do you understand? So we will assume that times 3 is a factor, right? So now we will again work on this series, and we will use times 3 to solve this question, right? So we have 7, and then we have 20, and then we have 59, then 176, 527. Let's work with these numbers first, okay? So what we are saying is that the ratio is 3. So if I do times 3, 7 times 3 is how much? 21. How do you get 20? Well, minus 1 gives me 20. That's correct. 7 times 3 is 21. 21 minus 1 is 20. Okay, let's multiply 20 by 3. What do we get? 60. And minus 1 is 59. It works. Okay, let's multiply this by 3. Use calculator again. 59 times 3 minus 1 equals to 176. Minus 1 is 176. Again, let's try this. 176 we already have now, times 3 minus 1 equals to 527. So that also works. So that means the formula that Tn is equals to Tn minus 1. If I multiply this number by 3 and then take away 1, it works. Do you see that? So that is the formula which represents this particular sequence. Now, whenever you write recursive formula, you have to write what T1 is. So the starting number here is 7. And what is n? N is greater than 1, right? Since for 1, I've already given you the value. You're getting the point, correct? So that is how you can develop recursive formula for a sequence, sometimes which is neither arithmetic nor geometric, right? So I hope that helps. Now, as an exercise, what you can do is, question number 1 for you is test if the other two values work, right? Test next 3 values. Okay. I should write question number 2. Write the 10th term. Okay. Write the 10th term. Okay. Using the formula, and also expand and then write all 10 terms using this formula, right? You can of course not write 10th term directly from this formula. You have to write first 9 terms to get the 10th one, right? I hope that helps. But here, foundation is being laid so that you can get some strategies to work with numbers, I should say sequences, and get a general formula for them. I hope this example helps you in doing so. Thank you and all the best.